Today's video lab it's more of a demo lab, chemical equilibria lab, observations of Le Chatelier's principle. When you shift an equilibrium, there are three different variables, three different stresses. Think to yourself, what are those three things? And we're going to be doing those three things to these various equilibria. We have three different equilibria and various shifts, things we can do, and you'll be able to see the equilibrium shift. Okay, so if you get out your worksheet, you'll see that the first equilibria is a complex one. It's cobalt chloride in solution, which forms a very complex equilibria between this weird Mongo polyatomic ion that's positive and pink, and this complex polyatomic ion, which is negative and blue. Now, looking at the solution, you can tell where the equilibrium position lies at room temperature and at this concentration. Okay, it's blue, so the equilibrium lies in this direction. So we'll shift it. We'll do all kinds of things. The first thing we're going to try to do is figure out whether this equilibrium is endo or exothermic. So we're going to take these two solutions and put one in a hot water bath and one in a cold water bath. And then it takes a while for the temperature changes to take effect, but you can see kind of right away that the hot one is getting darker blue, and the one in the ice water bath is turning kind of purplish, light purple, and eventually will turn pink. There it is, turning pink. Okay, so what we will do is we will change test tubes, and the temperature change from cold to hot is quicker. And so we see that the pink one turned blue in the hot water bath, and the blue one is getting lighter, and eventually will turn pink. Pause. So if we come up here, the hot water bath, the observation was that it turned blue. The chemical physical action is we add heat. And so the shift was, it went from blue to even bluer. So the shift was to the right. Okay, so right now we should be able to tell where is heat in this reaction. Should it be on this side or on this side? Think back to the notes. Turn to your neighbor, turn to yourself, where should heat go? And if you said heat is a reactant, because when you increase, it shifts away from the increase. So the explanation would be it shifts away from the heat as a reactant. Okay. Now, cold water bath. The observation was that it turns pink. Here we remove heat. The shift was from blue to pink. And then I'm going to leave the rest of the explanations for you. Pause. The next shift will be to add water. And if you look at water in our equation, water is one of the products in this equilibrium. So if I add water, see if you can make a prediction on what should happen. I will add water by the drop. And you can see very clearly that it turns pink rather graphically. Okay, pause. So coming back to the data table, we added water, it turns pink. Physical action was to add H2O. The shift was from blue to pink. So from product to reactant. So what did our Le Chatelier's principle tell us over here? So the next stress is hydrochloric acid. So we're going to take concentrated hydrochloric acid and we're going to add it to the solution that we just turned pink. That should tip my hand a little bit on what is going to happen, but let's see if we can figure out why. So if I get some concentrated HCl and add it drop by drop, as soon as the drop hits, you'll be able to see a change. And as it mixes, it goes away. Add some more. Mixes, goes away. Okay. So, adding HCl. If we go back to the whiteboard, adding HCl turns blue. It's the observation. Okay. What did we do? Well, the net effect is that we decreased increased Cl minus ion. When hydrochloric acid is in solution, it completely dissociates, giving hydrogen ion and chloride ion. So with the excess chloride ion, shift is this way, towards the blue. Okay, the next stress is to add nitric acid, or silver nitrate. This one's kind of funky. So again, I'll add them drop by drop. And you see a couple things happen. See the white precipitate? And then what color is the solution turning? So the formation of the precipitate is the silver ion combining with the chloride ion. If you think back to our solution unit, silver chloride is insoluble. Okay, so two things happen. A white precipitate and turns pink. The white precipitate was silver chloride, which decreased the chloride ions. So if you decrease, the shift is towards a decrease. Went from blue to pink. So the shift is this way. And then the last stress, pause. All right, the last stress for this equilibrium is to add calcium chloride. And it is also a rather strange mixture. Add the calcium chloride and immediately you'll see a change. And I needed to add it to this pink solution. And if you look at where the calcium chloride is, surrounding it is blue. So as the calcium chloride dissolves, the chloride ions, it's increasing the chloride ion in the solution. Pause. If I add more, then you can see it turns blue more quickly. All right, so back to the whiteboard. Add calcium chloride, turns blue. The chemical physical action is to increase chloride ion. The shift was from pink to blue, and then you can figure out the explanation. All right, now